Hey guys, so here's part 2 of the day 3 notes. We're talking about standardized normal distribution. So we left off on number 5 where we talked about when we had the DeLorean and we wanted to know what percentage will run below 68.5. Well, that wasn't necessarily on our normal curve. It was actually in between, and when we did the z-score, we got negative 1.5. Now, if we are using our math here and we really think, 1.5, since that's our z-score, so negative 1.5 means we're 1.5 standard deviations below the mean. If we kind of use that information, we could maybe try to say, well, 1.5 is in between 1 and 2 standard deviations. So maybe we could take that 13.5 and divide it by 2, and then add all the percentages afterwards, right? So the 0.15 and the 2.35%. So let's go ahead and do that and see what we get, okay? So we do, and we kind of already got that 2.5, but I'm just going to rewrite it because I like doing that. Plus 0.15. And then we said, because if, and this is just us thinking about it, if our negative 1.5 z-score, that is in between our 1 and our 2. So we could take the 13.5% and divide by 2. Now, of course, if we calculate all of this, well, 13.5 divided by 2, that gives us 6.75%, plus the 2.5%, we get 9.25%, okay? Well, let's see, using our new tool, which is now called the standardized normal distribution, because our 68, 95, 99.7 rule doesn't work here, let's see if we get the same answer as the 9.25%. I don't know. Okay. So first, let's talk about the standard normal distribution. What does this represent? Well, the first thing we do need to find is the z-score. So remember, we've been doing a lot of that. So the z-score is going to be the value minus your mean divided by the standard deviation. Okay? And when we do this, we do want to make sure we round to 2 decimal places. Before, it really didn't matter too much, but now we do want to round to 2 decimal places. Then, we are going to use a table, and I'm going to hand this out to you guys so you have it, but you're going to see it on here so you can see what it looks like. Okay, so we're going to use our standard normal distribution table, and from here, it gives us all the lovely z-scores, and then with that, what would occur with the percentage, okay? So basically this is the table, gives the percentage to the left, okay? So you'll see that here. So if we look at this, I'm going to just do this in red, okay? We have our z-score here. It will give us the percentage. Or another word they say is area, but we're not really thinking of area, we're thinking of percentage. But that's another way they might say the area underneath the curve or the percentage, okay? So it always gives, the table always gives the percentage to the left. Now, how do we read this table? Well, it gives us the z-scores, okay, on the left-hand side, but that's only up to the 10th place. If we need the next, which is the 100th place, then we go there. So let's say, going back to our answer we had, it said for number 5, we wanted to find C's less than, so that means values to the left. So we think about it here. So we do want values to the left. So using the table will be helpful because it only really finds the percentages to the left of the 68.45. So we figured out that the z-score was negative 1.5. Now we can go to our negatives, and let's see if I have that. Nope, I'm going to go ahead and show you guys with the negative side here. So when we have negatives, here we have our values. Okay, so we have negative 1.5, and that was our z-score. So I'm going to go down the z-scores, and because it was negative, so I go to where negative 1.5 is. I'm going to kind of show you here, right here. And because we didn't have anything in the 100th place, we basically go to the 0.00s to represent we didn't have anything in the hundreds place, okay? So it's saying that for negative 1.5, the percentage, and so here it is going to give us the decimal. We do need to move the decimal over 2 times to give us the percentage. So we get 0.0668, okay? But if we move that over, then we actually get 6.68%. Well, let's go back and see, was that the answer we got when we were trying to estimate from the normal curve? Okay. No, we got 9.25. So notice that the normal curve, we can't really, whenever we have standard deviations in between our whole ones, we can't really use our normal 68, 95, 99.7 rule when we get decimals as our z-score, because it actually does not work there. So really, our percentage here would have been 6.68%. Okay, so 9.25 does not work. So now let's go ahead and practice using our table to do some of these problems. Now one thing is, because I did say that it only gives you the percentages to the left, if you ever need to find the percentage to the right, what you would have to do is 1 minus the percent. Okay. Okay. And let me label these. These are, okay. Move decimal to the right 2 times to get, you might want to write this down. I kind of said it, but you might want to write it down to get percentage on the left. There you go. So as I said, they give you actually the decimal, but what you have to do if you want percentage is move that decimal to the right 2 times. Then you will figure out the percentage of the left-hand side, okay, or percent to the left. Okay, let's go ahead and try that for this. So what percentage of the runs will give you the DeLorean a speed of greater than 85? Now, let's kind of go back to our normal curve, okay? Notice we don't have 85 on our normal curve, so we know that 68, 95, 99.7 rule would not work here, so we have to use our new tool of the standardized normal curve. So the first thing we need to do is find the z-score. And remember, to do that, we take our value, which in this case is 85, subtract it from the mean, which I think going back was 80, and then divide by the standard deviation, which was 7.7. Okay. And once again, this is going back from our problem. So you plug this into your calculator, and I think we should get about 0.065 as our answer. Yeah, so just like if you were rounding any decimals, always round to the hundredths place as usual. Okay, so here's our z-score. Now let's think about what this would look like on our, if we drew like a curve here. So we know definitely 80, that is your mean. 85, if we're at 0.65 as our z-score, here is 1 standard deviation. We're not quite there though. So we want to make sure, oops, sorry, I made that mistake. Okay, so from here we have our 85, and we can kind of also use our normal bell curve to kind of see where everything is listed. So we have 80, and then our 87.7, so our 85 is like at least in between there. So here is, let's just say our 85 right here. Okay. And because we want greater than, we want values to the right, right, because of greater than. So remember when we use the table, it only tells us values to the left. So remember, to do this, we will have to do 1 minus the percentage. Well, let's find the percentage of our 0.65. So using our table. So I'm going to go back here, 0.65. So I go to the 0.0, or sorry, I go to the 0.6, and then I need to go to the 0.05. So I get 0.7422, okay? So I'm going to do 1 minus the, in this case, the decimal, 0.7422. So this is the area to the left. To find the area to the right, I'm going to take the 1 minus 0.7422, get that decimal, and then change it into a percentage. So plug that into your calculator, that's fine. You should get about 0.2578. And once again, I move the decimal 2 places over, so I get 25.78%. Okay, so now let's go ahead and do number 7. I would like you guys to go ahead and try this one on your own, so pause the video to do so. Okay, so what percentage of the runs will give the DeLorean a speed between 70 and 95? So I like to go ahead and kind of just draw this out. We know 80 is in between. I'm going to use different colors. Well, 70, that's going to be a value less than, and 95 is a value greater than. So what we're trying to do is, if we're trying to find a speed between, we want this area here, okay? Now let's see what we can do to find that. Well, because we have two numbers, we have to find the z-score of both our 95 and our 70. So let's first try the 95. So I do 95 minus 80 divided by the 7.7. Calculate that, I get 1.95. Okay, now the z-score for our 70, we do 70 minus 80 over 7.7, and that gives us negative 1.30. Okay, now let's find basically our areas to the left. So we're going to find the area that represents the 1.95 z-score. And remember, this all represents our left. So going to our table, so I go to 1.95, and then I need to go over the 0.05. So I have 1.9, and then I have 0.00, then 1, 2, 3, 4. Here's my 5. Okay, so I'm at 0.9744. So that's the area to the left there. Now let's do negative 1.30. Okay, I'm going to change this. Okay, so negative 1.3, so I'm here, and then my 0, 0. So I have 0.0968. So that's the area to the left for that z-score. Now, in order to find the middle, what we're going to do is subtract the two values. Because if you subtract the entire left minus that tidbit left after 70, we will get our in-between. So I'm going to do 0.9744 minus 0.0968. Now we also know our percentage has to be positive. It would make sense to have like a negative percentage. So it probably would make sense if we are subtracting, do the larger minus the smaller value. And when we do, we get 0.8776. And we change this into a percentage, so we get about 87.76%. So yeah, change things into a percentage at the end of the problem. Okay, now let's go ahead and do our last problem. And once again, I would like you guys to go ahead and pause the video and try this one on your own. Okay, so we have a little bit of a different problem here. It says when professional golfer Jordan Spieth hits his driver, the distance the ball travels can be modeled by a normal distribution. So even if we're using a standard normal distribution, we still have to make sure it's a normal distribution with a mean of 304 yards and a standard deviation of 8. On a specific hole, Jordan would need to hit the ball at least 290 yards. To clear a safe shutdown avoids a large group of trees. What percent of Spieth's drives travel at least 290 yards? Okay, so we can draw our normal distribution and see if we can use that 68 and 90 or 95, 99.7. Okay, so I have my middle, my mean is 304. Now 290 is smaller, so I'm just going to worry about the left, and if 290 is not part of my normal distribution, then I'm going to do the standardized normal. Okay, so I do 304, and I subtract that. I think our standard deviation is 8, so I do 304 minus 8. That gives me 296. Okay, let me try it one more time. 296 minus 8, that gives me 288. Okay, so 290 is not specifically on our normal bell curve here. So we can't use the 68, 95, 99.7 rule. Instead, we will have to use the standardized normal. So that means we first need to find the z-score. So we're going to take the value, subtract it from the mean, and divide it by the standard deviation. Plug that into your calculator, we get about negative 1.75. Okay, now from there, we need to determine, okay, what we need. Now, it says that we want at least. What does that really represent if we want at least? Well, that means we want 290 and anything bigger. So that means we want the area underneath the curve to be on the right-hand side of our value. So in order to do that, we still need to find the area, but then do 1 minus that to get our values on the right-hand side. So I go ahead and do negative 1.75, and I go to my negative spot. So I go to negative 1.7, and then we're at 0.005. So I go over 0, 1, 2, 3, 4, 5. So I'm at 0.040, and I think that's a 1. It's kind of hard to tell. Sorry, guys. Okay, so now from here, I know this z-score is about, or sorry, this percentage is 0.0401. Need area to the right. So I do 1 minus that. And that gives me 0.9599. And so I change that into a percentage. I get 95.99%. That's my final answer. Okay, make sure you guys work on the homework assignment, and if you have any questions, make sure you contact me. I'll see you guys later.